Hey everybody, this is day 22 of our astronomy unit. I'm Andy Pilc, and in today's video, I'll be going over what happens when you don't listen to your earth science teacher's advice when they tell you not to go too close to a black hole. So pretty much, a person that gets too close to a black hole will turn into that long shape of noodle that we all know and love in a process called spaghettification. And in order to understand how this happens, I'm going to first switch gears and go back to my favorite PhET simulator, which shows how mass will affect gravity and will change the fabric of space-time. So in one of our previous lessons, we learned about how objects interact with space-time, and more massive objects are going to bend the fabric of space. So if we were to add more mass to our sun, we're going to see an increase in gravitational attraction between the sun and the earth. If we talk about black holes are extremely massive, so much to the point that a photon of light couldn't escape the gravity of a black hole, even though it's traveling at the velocity of the speed of light, about 680 million miles per hour. So black holes, they're super massive, they're going to create a lot of gravity. And remember, the second thing that's going to affect the gravitational attraction between two objects is the distance between the two objects. So as objects are closer together, we're going to see an increase in gravitational force. And as I increase the distance between the two objects, we'll see the gravitational attraction between the objects decrease. So back to spaghettification. First off, if you didn't notice, this was the first photograph ever of a black hole taken by the Event Horizon Telescope collaboration just this past year. But let's talk about what happens if an individual was unfortunate enough to enter the event horizon. Now, the event horizon is the boundary at which light and no other object can escape the black hole. So once you get that close to the black hole, the fabric of space has bended so much so that you can't escape the gravitational force, and therefore will start accelerating towards the black hole. Now, since it's so massive, the effective gravity is going to affect the different parts of it individually differently, because technically they're different lengths or different distances away from the black hole. So if you were to see this individual's hand, for example, their hand is such a distance away from the black hole, but their foot is even closer to the black hole. So because of that, the gravitational attraction on the bottom of the person's body is going to be greater than the gravitational attraction at the top of the person's body, because there's so much gravity that even though there's such a small distance, it's still going to have an effect on the acceleration caused by gravity. If we were to think about the person's head all the way up on top, the furthest point from the black hole, that would be accelerating the least amount. So because of this, as the person gets pulled towards the black hole, they're going to actually have their cells and their body rip apart, because different cells are going to be accelerating at different amounts of time. And the theory is that this individual will very quickly turn into a very long one-cell strand of spaghetti. So that's one little concept that astrophysicists kind of toy around with when talking about the gravitational attraction around black holes, with a fun name, spaghettification. So we'll end today just excuse me, by looking at a couple practice regions questions. We saw this one the other day talking about the expanding universe straight out of the regions. So we have this diagram here. Identify the name of the event that is inferred by scientists to have occurred when the universe first formed. Well, this diagram showing the expanding universe and the universe first forming would be showing us the Big Bang. The Big Bang was the event. The school of thought that this happened was the theory of the Big Bang. One piece of evidence that led astronomers to infer that the universe is expanding. There are a couple, but the two that always come up on the Earth science regions, one is the redshift of galaxies. So as stars and galaxies are moving apart, and all of the galaxies that we look up in the sky are moving away from us, there's a redshift of their spectral patterns. So therefore, that's telling us that all of the stars and galaxies are moving away from us, and therefore the universe is expanding. The second piece of evidence is the cosmic background radiation, or the cosmic microwave background, which is leftover heat, some remnants from the Big Bang that happened about 14 billion years ago. Identify the force that caused stars and planets in the universe to become layered according to density differences in their composition. Usually when the Regents is asking about a force, they're talking about the force of gravity. And in this case, that would be the reason why we see density differences in planets, in the universe, in the solar system, because of the force of gravity and the effect that it has on the fabric of space-time. And lastly, the process, the nuclear process. Again, there's usually only, I'm not going to say that there's only one process that we talk about in Earth science, but when it comes to like space science and astrology and stars, the nuclear process that combines lighter elements into heavier elements to produce energy is the process of fusion, nuclear fusion. When stars first, the force of gravity pulls a nebula together, and when the matter inside that nebula compresses due to the force of gravity, it's going to squeeze together. When the force of gravity becomes so great, it's going to cause the hydrogen atoms to fuse together and form helium. And in that process, it's going to release energy. As soon as that, what we would call a protostar, as soon as it fuses those elements together and creates energy, then we have a star, we have a nuclear furnace, and it will continue to burn for billions of years. So I hope you found this video helpful. I will see you next time. Have a nice day. And that's all I got. Bye.